Hi, we are now going to review the tutorial file, which is the cache design. So in this question, as you can see, we have a machine with a word size of 16 bits, okay, and address width of 32 bits. And the direct map cache, as you can see, has 16 blocks and a block size of 2 words. Okay, so let's decipher what this data and what information it gives us. So the first thing is we have a direct map cache, okay, with 16 blocks. So that means that we have a cache that has a total of 16 blocks. That means from 0 all the way to 15. Now to have 16 blocks, okay, which means that in my cache, when I look at the address, I need to break it up, okay, as we know, into three things: the tag, okay, the cache line, okay, and then the byte offset. Okay, so since I have 16 blocks or 16 lines, so I know that 2 to the power of 4 is 16. So I need 4 bits to represent the cache line, and in each cache line I have 2 words, okay, 2 words. And you know that since one word is 16 bits, 2 words is 32 bits, okay, and 32 bits is equivalent to 4 bytes, and 4 bytes is actually 2 to the power of 2. That means I need 2 bits to represent the offset, the byte offset, and the remaining 26 bits will represent the tag. Okay, so that is the first thing we need to understand from the question. How do I get an idea of the bits mapping to the tag, the cache line, and the offset? So I repeat, since I have 16 blocks, which means 16 lines, and 16 lines is 2 to the power of 4, so I have 4 bits for the offset. Next is 4 bits for the cache line, and after that for the offset is the byte offset within the cache line. And in one cache line I have 2 words, and in this question one word is 16 bits. That means 2 words is 32 bits, which is 4 bytes. So for the byte offset, to select the byte that I want, I need 2 bits, okay, for the byte offset, and the remaining will be for the tag. Okay, now the other important thing is understanding where the memory will be mapped to inside the cache. So as you can see that since I have a offset of 2 bits, that means 4 bytes per cache line, basically means that the last 2 bits 00, 01, 10, and 11, when the last 2 bits ranging from 00 to 11, they will map to one cache line, and inside that one cache line, okay, I need to break it up into 2 words. One is word 0 and this is word 1. Okay, so let's look at the memory accesses to see how we can go about it. So the first memory access here, as you can see, is memory address 4. Okay, so memory address 4, in here we have already broken it up to give you the byte offset as well as the cache line. So this maps to cache line 1. Okay, and in cache line 1, so in when you first start up the system, of course everything will be initial cold miss or compulsory miss. So cache line 1 will originally not have any content. So what we will do is we will need to update cache line 1. Okay, so as you can see, for in this example, the byte offset is 0, which is pointing to this location here. So this location here means that the memory data and memory address 0 will be mapped to word 0. Okay, so what I will have here is memory location 4 and memory location 5. Okay, and at the same time I have memory location 6 here and memory location 7. Okay, so when I write M4, M5 and so on, that means the data in address 4 and data in address 5 will come to word 0, and the data in address 6 and address 7 will come to word 1. Okay, and the tag value in this case is 0, because if you can see here, the upper bits here are all 0. Okay, so that is the first access. Now let's look at the second access over here. So in this we have the address location hex 5C. So 5C maps to line 7, okay, offset 0. So line 7 here, okay, so I'll come here, and in line 7 I will then update the information. So you can see that this address location here also has a byte offset of 0. So it is also talking about the word 0 here. So that means what I will see is I will have data from memory location 5C, okay, and memory location 5D here, and then memory location 5E, and then 5F. Okay, and the tag value, okay, if I look at the upper bits here, the tag value here is 1. Okay, so I'll put the tag value of 1 over here. Now let's look at the next access. The next access is in address location 7. So address location 7 is mapped to cache line 1, okay, with a tag of 0. So you can see that cache line 1 has some data and the tag is 0, so we consider it as a hit. Okay, so coming back here, you can see that the first two were misses and this one is a hit. Okay, so since it's a hit, the data is already in the cache over here, and I can just take this data and return it to the processor. Now let's look at the next access over here, which is hex 92. In this case, we are mapping it to line 4. Okay, so in line 4 here, what do I see? I'm having a tag of 2, so the tag is 2, and this address I'm talking about is 92, so the last two bits are 10. So coming back over here, 10 is pointing to the first byte of word 1, correct? So what I need to do is I need to put memory location 92 here, okay, followed by 93, okay, and then memory 91 here, and then memory location 90 over here. Okay, so that is how I populate this particular cache line. So you need to see very carefully the byte offset, and from the byte offset, okay, you need to see where it maps to within the cache line. Okay, so that was also originally a miss, okay, and now that I've updated it, it will become a hit. Okay, for the next address location 1E, so the same thing, cache line 7, okay, offset, okay, of 2. So in cache line 7, what do I see? Okay, in cache line 7 here, okay, let me change the color. Okay, cache line 7, currently I have some data there, but the tag is currently 1 and this tag here is 0. Okay, that means I need to now replace this cache line. So from 1 it will become 0, and again this data needs to be updated, but this is 1E, so the last two bits are 10. So since they are 10, they are again pointing to here, correct? They are pointing to the word 1 first byte. Okay, so the 1E will come here, so 1E and 1F, followed by 1D here and 1C. Okay, so that is your access over here. So this will be a miss, okay, because I need to replace the cache line. Now let's look at the next access here. So in this next access, I'm going to look at address location 5F. So 5F, as you can see, again comes back to cache line 7, but the index is now 1. So cache line 7 and the index is 1. So again, I need to do another cache replacement. So this one will become 1 again. And this time round, 5F, the last two bits are 1, 1. So since the last two bits are 1, 1, it is referring to the second byte of word 1. Okay, so the data 5F will come here. Okay, then followed by 5E over here before that. Okay, then 5D, and then memory 5C. Okay, so you can see again, though they are in separate line, all of this are mapped to the same cache line 7. Okay, it's not 7, 8, 9, all three are actually in cache line 7. Okay, so that's what you can see here. So again, this is a miss. And let's look at the next one here, address location B0. So in address location B0, I'm mapping to cache line 12. Okay, so cache line 12 is currently not allocated anything, so I will now be able to update it. So the tag is 2, and in this case, since the byte offset is 00, I straight away start from here. So this is memory B0, okay, followed by B1, and then B2 and B3. Okay, so this is also a miss. The next access 5D. Okay, so 5D, you can see it maps to cache line 7 with a tag of 1. So cache line 7 with a tag of 1. Okay, so it is currently in the cache, so this is considered a hit. Okay, so the content, which is 5D, which is this, will be returned back to the processor. Okay, the next one, hex 91, maps to cache line 4 with a tag of 2. So cache line 4 with a tag of 2 is also a hit. Okay, and this data 91 will be returned back to the processor. How about this 264 hex 108? So this hex 108 maps to cache line 2. Okay, cache line 2 with offset of 0 and with a tag of 4. So cache line 2, tag of 4, and I need to update the address. So this, since the last 2 bits are 0, so it is basically memory 108, okay, 109, okay, 10A and 10B. Okay, so this is actually a miss. Then after that, I populate the cache, and the last access address location 6, you can see that it maps to cache line 1, okay, with a tag of 0. So cache line 1, tag of 0, it is a hit. Okay, so the data that I want, which is in byte 2, okay, is here, and this will be returned back to the cache. So this is a hit. Okay, so that is basically how you go about analyzing this question. So you can see that as long as you get the first step correct, which is the breaking up of the address into the tag, line, and offset bits, and you also get this part correct, then subsequently it's just a matter of analyzing each address and seeing where it maps to know whether it's a hit or a miss, and how you update the cache line accordingly. Okay, so I hope this gives you a better understanding of the tutorial that we went through in class. Okay, thank you.